Let's do a quick review of polynomials. Polynomials, these guys have the form of a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus yada 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 plus a1 x to the first plus a naught. Well, actually, usually it's typically simply written as a naught, but in reality, we could think of it as x to the 0, which is 1. It just kind of maintain that pattern that we just established there. Now, all of these a's, I'm going to say the ai's, all these guys are going to be real numbers. They're elements of the real. This little script looking R thing, if you haven't seen this before, this means real numbers. And an, this guy in the end here, has to be non-zero. Any of these guys, an minus 1 through a1 and a0, all these could be 0. That's not a big deal. And also, n is an element of the positive integers. That's supposed to be a script I, which is difficult to write. Positive, which is another way of saying the set 1, 2, 3, 4, the counting numbers. So, as a quick example here, something like x cubed minus 3x plus 1, that's algebraic, or I'm sorry, that's a polynomial, whereas the cube root of x minus 3x plus 1 is not a polynomial. The reason it's not a polynomial is if I rewrite this, this is x to the 1/3, and that's what violates it, because n in this case is a fraction. It's not a whole number. Here, x cubed is fine. An in this case is going to be, well, an is going to be 2 here, a2. Oops, I'm sorry, 3. A3. Sorry, I kind of made a mess of that. Let me fix that. There we go. A3 in this case equals 1. A2 in this case equals 0. A1 in this case equals 3. And A naught in this case equals 1. We're here, A3 equals 1/3, and there again, that's the violation. Now let's take a look at the idea of rational functions. And again, just like polynomials, this whole chapter I'm going through here is just a really brief review. It's really not meant to be very instructional, just kind of get you thinking like this again. See, f of x is a polynomial if it's written in the form of p of x over, I'm sorry, I said polynomial, I meant rational function. If it's written in the form p of x over q of x, where the functions p and q are polynomials, and of course q of x is non-zero, because then if it's 0 we have an undefined situation, or possibly if it's 0 for 0 an indeterminate situation to deal with. Now, just in terms of definition and in actual practice, it's kind of two different things here. If I say f of x equals, let's just make this x cubed plus 2x minus 1 divided by the square root of x plus 2, by definition this is not a rational function, because this piece right here is x to the 1/2, and that is not a polynomial, because this has to be an integer. Even though by definition this is truly or technically not a rational function, we always treat it as if it was a rational function. It's actually an algebraic function. Now, an algebraic function covers all those things that are not polynomials. So, as an example, if I took f of x equals the cube root of x minus 3x plus 1. Let me fix that radical because that was really ugly. There we go. This is not a polynomial because this thing right here is actually x to the 1/3, and this is not a positive integer, so it's not a polynomial. It's an algebraic function. If I simply write the cube root of x minus 3x plus 1 and not write it as a function or equation, then this is simply an algebraic expression. This is a function because it's written in function notation. Now, all polynomials written in the form f of x equals an x to the n plus a n minus 1 x n minus 1 plus yada 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 plus a1 x plus a naught are also algebraic functions. It's a function because I set it up as a function. F of x equals this thing. And it is also algebraic. It's just that the group of algebraic functions also includes non-polynomials. Exponential functions have the form f of x equals b to the x. Specifically, let me fix that x, that was nasty. There we go. Specifically for b greater than 0 and b not equal to 1. That's the definition of an exponential function. The value b is referred to as the base. So if I said f of x equals 2 to the x, then in this case 2 is b. That's the base. If I say g of x equals e to the x, that's also an exponential function. In this case, e is simply the base in this case. Now, trig functions. The trig functions are sine x, cosine x, cosine x. All other, there's 6 of them. There's 1, 2. The other 4, 3, 4, 5, 6 are actually functions of sine and cosine. Tangent of x is sine over cosine. Is to secant of x. Well, that's actually 1 over cosine. There's cosecant of x. That's 1 over sine. And cotangent of x. So here's the 6 trig functions. I'll talk a little bit more in detail about these functions and define them for you a little bit later in another video. Let's see, then we have the transcendental functions. Transcendental functions are really pretty simple. It's all functions that are not algebraic. So what does that mean? Well, all the trig functions are non-algebraic. Exponential functions are non-algebraic, and with the exponential functions come all the log functions. And there are others, but this is the biggest group of transcendental functions that we'll actually be working with.